Hi all, welcome to the sixth part of the video lecture on transaction management. So in the previous two parts we discussed about the concurrency control mechanism based on locking, and we just started discussing, so where we introduced the concept of binary lock and shared or exclusive lock. Now let's see the formal protocol that we are using, the two-phase locking protocol, which by default ensures the serializability. And what is the serializability, you know already, right? And how the serializability, particularly conflict serializability checking, can be done, that also we discussed in the first two parts of the video lecture. So now we will see how this two-phase locking protocol is going to ensure serializability. So first let's see what is a two-phase locking protocol. A transaction is said to follow two-phase locking protocol if all locking operations, whether it is read or write lock, they all precede the first unlock operation in the transaction. In the sense, you are not allowed to lock as well as unlock in any manner as you wish. So you just have to complete all the locking process. I mean, whether it is read or write lock on any number of data item, that you have to finish first. Okay, so in between you can do some other operations also. In some order, this locking will go through. So that is your first phase. And the second phase is the unlocking phase. So before starting the second phase, or before starting the very first unlocking, you should ensure that all the data needed for you is being locked. Okay, so that's all. So all the locking operations should happen before the first unlock operation in the entire transaction. So every transaction should follow this rule. So that's all. So accordingly, we will be getting two phases for the transaction, say a growing phase or an expanding phase, where the transaction will try to acquire all the locks it is in need of, right? So during which the new locks on items can be acquired, but none can be released. That because the release operation or the unlock process will be in a different phase, a shrinking phase. And growing and shrinking should occur one after another. So during that growing or expanding phase, whatever things you want, that you will lock. And means there is no restriction like before starting the transaction you have to lock everything. So that is actually a different variation of this two-phase locking, we will see. But the default two-phase locking says that you have to lock everything in between, in any order you can lock them in between, in an interleaved manner you can do other operations also, but you have to ensure that all locking of all data required by this transaction should happen before the first unlock. And the first unlock onwards, you will start unlocking the data as whenever it is no longer needed. In your own way you can unlock them. So that should proceed in a different phase called shrinking phase. Okay. So already in the last video lecture we discussed about lock conversion. Say from a shared lock we can upgrade the lock to exclusive lock if same transaction want to lock the same data item in a write purpose, and suppose it is already holding it for read purpose, we can promote the lock, right? So upgrading. Similarly, at some point you want to have that read operation, but it is already locked for write operation, you can downgrade also. So these lock conversion will now happen in a particular way, like so you think about it. So in expanding or shrinking phase, this lock upgradation will happen. Similarly, whether in expanding or shrinking phase, this degrading is going to happen. You can observe that the upgrading of the operation, see the upgrading of all the lock, that upgrading operation must be done during the expanding phase, because during expanding phase the lock is being acquired, and that time if you want to change the status, like from read lock you want to promote it to write lock, that you can do in the expanding phase. Because whether it is lock upgrading, basically it is acquiring the lock, right? Maybe from one status to another status you are it's a kind of acquiring lock only, but basically we already acquired and we are trying to acquire it again for a more restrictive purpose, say for a write purpose. So like that. But but what about the downgrading operation? That should happen in the shrinking phase, because downgrading is something like you already have that data in a write locked manner and you want to downgrade it to read lock, right? So this is some kind of unlocking. So by default it should happen like a write lock the data you have to unlock, and then you have to change it to read lock. Okay, so that you are doing without having that unlock in between, so that it should happen in the shrinking phase, because shrinking phase is exclusively for this unlocking purpose. So that's why the upgrading will happen in the growing phase or expanding phase, and downgrading of the logs will happen in the shrinking phase. Okay, hope it is clear. So here you can see say two transaction T1 and T2 which are not obeying two-phase locking, and we will see what is the problem with something like this, and when we impose two-phase locking, how it is going to ensure serializability. So that we will analyze with the help of this example. So here you can see the execution of T1, two transaction T1 and T2, and you just observe the pattern, see how this assume that we are it is just using two data items, say x and y, and initially let the value of x be something like 20 and y be 30. Okay, so that is the initial assumption we are having. Accordingly, let's execute let's see the result of the serial schedule, say T1 followed by T2. T1 finishes and then T2 starts, like that, and let's see how we are obtaining this result. So T1 is starting, right? So what T1 is doing, understand each line. So it want to do something on data item y. Do in the sense it want to read the data item y. So what it will do, it will read log y, and after that it can read that, right? So it want to execute read item y, but before that it is supposed to lock it, right, for making that concurrent execution possible without any issue. Now after the purpose is over, after that reading is over, it is unlocking the data, fine, that particular item. Now it want to write or modify the data item x. Accordingly, before modification, it has to write log the data. Now you can see that two-phase locking rule is violated, because two-phase locking says that before starting the first unlock operation, before starting the very first unlock operation, say this is the first unlock operation, I am supposed to lock all the data item I am in need. So here I am in need of y, and I want to read log y, and similarly I want to write log x, but this write log is supposed to execute before this unlock. So that is what is the requirement of two-phase locking protocol, but that is not followed here. So it is not a two-phase it is not a schedule that is following two-phase locking. It is just an ordinary schedule. Whenever I want, I will lock and I will unlock as per my requirement. So let's see how it is working. So I write log the data, and then I want to modify this x, right? So that's why I done that write locking, and once you done this write locking operation, you are allowed to read also, right? So I am reading that x value, then I am modifying x with x plus y. Now you can update x by adding x with y. So you already read x value and y value, and you are adding them, say 20 and 30, and you are updating your x accordingly. So x will be now 50. So x is modified like this when T1 is executed, and that update is written back also. So once the process is over, you are just unlocking x. This is what is happening, and it is not following two-phase locking protocol. Okay, simply it is locking and unlocking, that's all. Now following T1, I am executing T2. So what T2 will be doing is, T2 will assess a separate transaction, it will read log the data again, and it is reading x. It is reading x, so that it will be getting x value as 50, because it is updated like that by T1. And after that reading is over, it is unlocking that x. Then it is write locking y, in the sense it want to update y. Okay, so and it is reading y also, and it is updating y by adding x value with the y value, and what is x value, which is updated to be 50, and the y value, there is no update done by T1. So y value is still 30. So when you add both, y will be updated to 30 plus 50, 80. And then you are writing y value, and you are unlocking it back. Okay, so this is what is happening. Now let me remove all these updates so that I can execute the second category. Means what I am doing is, let's see what will be the result of execution. Suppose we have the serial schedules where T2 is followed by T1. Okay, so T2 is executing first, and now you know how this execution is happening. T2 is reading x. Before that, it is read locking and unlocking. after use. So that you will be getting x as 20, and it is updating this y value with the 20 plus 30. So y is updated to 50. Okay, and accordingly it is locking and unlocking the item, and after that T1 is executed, so that T1 is reading y, and y it will get the updated value, that is 50. Right, at this point it will get y value as 50, and then it is unlocking that y. It is free now, and it is right locking x value. There is no change by t2, right? So x is 20 only, so it is updating x to 20 plus 50, so x will be updated to 70. That's all. See, this is what is happening. So let me remove these changes also. So hope this example is clear. So initial value, this is the assumption we taken, and if we followed the serial schedule T1 followed by T2, the changes will be like x will be updated to 50 and y will be 80. If it is T2 followed by T1, this is the update we are expecting. Now let's see on non-serial execution and see whether it is equivalent to any serial schedule that is explained before. So in the non-serial schedule, what we done is the first 3 line of T1 is being executed, so till this, and after that T2 is executed completely. Say, I mean here we are interleaved to T2, and after finishing T2, I am coming back and I am executing these remaining steps. So this is what is done. See, you can see the first 3 steps, then T2 is executed completely, then I am continuing T1. Okay, so I hope you understand how this same transaction only, just a non-serial schedule. And let's see how these x and y values are updated now. So we are expecting the result to be either that is x is equal to 50 and y is equal to 80, or it is 70 and 50, because both are valid, in the sense both are resulted out of some serial schedule, and we are going to see whether this non-serial schedule is equivalent to any one of them before. But unfortunately, you can see it is not equivalent to any of the serial schedule, and the result is something found to be 50-50. Okay, so you know it is not like 50-80 or 70-50. So it is some different execution, or it is not a serializable schedule. Right? Serializable means it's a non-serial schedule, whether it is equivalent to any serial schedule. The answer is no. And you can execute, right? So how we are getting this 50-50? Let me quickly explain. So first I am reading y value. So the initial value of x and y, you have to assume like before, 20 and 30. So x initial value is 20 and y initial value is 30, so that when you are reading the item y, you will get this 30 in y, and then so this transaction T1 read y value as 30, maybe in its local variable. Then you are switching to T2, and T2 is locking read locking x, and it is reading x will be 20, right? So here it will get x as 20, and then it is right locking y, and it is updating y. And see, when it is updating y, this y value will be updated with x plus y. So what is x plus y? That is 20 plus 30. Y is updated to 50 by T2, and it is writing that updated value in the database, and it is unlocking. But when it is coming back here, see what is happening. Even though y is updated to 50, that this update is not available to T1, because for T1 the local value variable says that the y value is 30. This update is something missing, right? So what T1 will do is T1 will read x again, so it will get x as 20, because this is the updated value, and x and y it will be adding, and it is updating to x value, so that this will be updated to 20 plus 30, that is 50. But actually if we are getting this updated value 50, then it will be nice, right? So but we are not getting like that. So that is a problem with the this why it is happening, because it is not following two-phase locking. So or I can say that this particular non-serial execution is not equivalent to any serial schedule, so I am not supposed to proceed with this one. So I am not going to allow this particular non-serial schedule, or it is not it is not a serializable schedule. Okay, maybe you can do this checking by drawing the graph also. That complex serializability checking you can do by drawing that execution graph and checking for that cycles. Okay, that will also give you this solution. Anyway, I hope you are able to follow this. Now let's see what the miracle that is going to happen when you are making the schedule. When you are restricting the transaction to follow that two-phase locking. If the transactions are following two-phase locking, always the corresponding non-serial schedule, provided it is following two-phase locking, is guaranteed to be serializable. Okay, so it will never lead to a non-serial schedule which can't be converted to, which is not equivalent to any serial schedule. Okay, so it will always ensure serializable schedule. And why it is so? Because let's see, we modified the T1 and T2 in such a way that we just reorder the locking process, that's all. So now this T1 dash is nothing but our T1 only, but you can see that read item, before that unlock, I shifted that right lock before that unlock. So I already told you, because for the condition for two-phase locking is, before the very first unlock operation I am supposed to complete all locking operations. So here you can see that after that unlock there is a lock. This should not be the case when it comes to two-phase locking. So two-phase locking says that every locking operation should be before the first unlocking operation. So the process will be continuing in a growing and shrinking phase. In growing phase you will do all the locking, that you can do in any order, and in shrinking phase you will do all unlocking, okay, and there is no interleaving. So that's only modification we done to make this T1 to T1 dash. So what we done is this right lock is moved before unlock and then unlock. So that's all. Similarly here also you can see this unlock operation, before that this right lock should happen, like that. So in this example we just have to do these two modifications so that the schedule is just follow, it's just going to follow two-phase locking. Okay, so that's all. So the remaining things are kept as it is. So like that T2 is also updated. Now let's see what is going to happen if I have a non-serial execution like this. So now the problem is, if I want to interleave after this unlock, if I am interleaving, so let me use a different color just to explain you the concept. Say I want to interleave to T1 T2 after this unlock, and you know this write operation I moved before this write at this point. So when it comes to two-phase locking, this write lock is going to be before unlock. So if I want to interleave or move towards T2 after that unlock operation, definitely that write lock will be executed before. Now you know, as the item X is already, so you have to assume a schedule. I mean, if I want a requirement like this, definitely if I am following two-phase locking, this write lock will be happening before this unlock. Okay, hope it is clear. So this is our two-phase locking, means this is our growing phase. So let me write it as growing phase. Maybe I'll be writing later. And this is my shrinking phase. Okay, shrinking phase where all unlocking will be happening. So this is what is happening. So if I want to interleave to another transaction after unlock, definitely this is going to happen before it. So that is the catch here. And if I try to read lock X again, so this will not be succeeded. So because the item is already write lock by T1, so I can't do this. Okay, so that is the peculiarity of locking protocol. Read lock you can do any number of times, but if the item is already write locked by some other transaction, a new transaction is not allowed to read lock the same item, because it has to wait until it is released by this transaction 1. So that this is, you can't execute this at this point, okay, you have to wait for executing this. So once you are waiting, you know what will happen. You can't do this because you can't proceed further without executing this particular operation, right? But this operation you can't execute at this point. You can execute it only after the item X being released by transaction 1, and you can see that the item X is being released by transaction 1 at this point only. So now only X is free. After that only you can do this. So when you are postponing this read lock operation after this unlock, definitely it is basically T1 followed by T2. So it is something like a serial schedule. Okay, T1 followed by T2. So it is going to be equivalent to T1 followed by T2, say it is serial schedule. So it's a serializable schedule. So hope you are able to follow this, right? So this is a speciality of two-phase locking. So that is because of that requirement, because when I do all locking before the first unlocking, if someone else is trying to lock it, it will not happen, so that the first one should finish, then only finish, or it at least it should release a lock. Whenever it is releasing the lock, this releasing lock can happen at some point before also, and then after only T2 can proceed, and that time it is safe, right? There is no it's not going to be a non-serial schedule. So hope this example is clear, or you watch it again. Still any doubt you can clarify with me directly. Yeah. So this is what I was trying to say. If I am making the schedule two-phase, following the two-phase protocol, in the sense before the first unlock operation I am doing all the locking operation, then I am proceeding with unlock. So from this point onwards you can see only unlocking operation. So before that no locking will happen. So this is something known to be our growing phase or expanding phase. And this is our shrinking phase, right? So like that it will proceed in two phase, so have this name. Now let's see something special here, something But I can tell you there is another issue that normal with the all two-phase locking protocol, it may lead to deadlock. And the deadlock, the situation that you might studied in operating system and all, nobody is able to proceed, right? So two process, say process 1 is trying to get a resource, say x and y. So process 1 need both and process 2 also need both, then only both can proceed. So what is going to happen? Process 1 is holding x and it is requesting y. It is requesting y. After getting y only it can proceed, but y is being held by process P2. Maybe let me use the arrow like this, like process 1 is holding x and process 2 is holding y. This arrow says so, and process 1 is requesting y. After getting y only it can proceed. Only with the x, process 1 can't proceed. Similarly, process 2 can't proceed only with the resource y. It is requesting x. So what is happening? Both are not able to proceed. So this is some kind of deadlock. Both are not going to release that resource, and at the same time they will be requesting what is held by others. Okay, something like this here you can witness. See, instead of process 1 and 2, here we have transaction 1 and 2, and the resources are our data items. Okay, so that's all. The same phenomenon you can see. So here you can see what suppose let me take a serial execution, and the serial execution is like this: T1 dash and T2 dash, and what I am doing is first I am executing this say read lock of y, and say let me just give you the schedule now. Let me pause it and write it. See, the situation is like this. Okay, so what I done is I just given you a situation where this deadlock can happen. Okay, so observe it carefully. See, I just executed. So this is our timeline, right? So first I executed read lock on item y. So this first line. Then I read the item also. So that you can do at any point. But anyway, I'm doing it now. Then I switched to T2. So because it is a non-serial execution, so something like this can happen. And then I did this read lock on X item, and I am reading it also, but I didn't unlock it. Now, if I am coming back to this, after following this, the next line I will be executing is, I will be trying to execute this write lock on X. Can it do it? Because the item X is already read locked by T2 dash. So T1 dash can't do this write lock. Okay, so this line it can't execute. Similarly, if it is switching to T2, it want to write lock item Y, but item Y is already read locked by T1 dash and it is not released it also. So this step also you can't proceed. So it's in a deadlock state, something like this. So what is needed for T2 is being held by T1, and what is needed for T1 is held by T2, and both are not able to proceed further. So this is our deadlock situation in a different way, right? So something like this can happen when it comes to two-phase locking protocol. Now can you tell me a solution for this? So what we can do, just like you might studied in operating system, so something similar you can apply here also. You can ensure that or you can give a rule like a transaction before starting execution of any step of this transaction. For example, the read item is a step of the transaction. So before starting the actual transaction, you are supposed to lock everything that is needed for you, and you can lock all item provided you are getting everything. So suppose you are getting y and you are not getting x, you should voluntarily release y also, so that let other person can continue at least. Okay, so that kind of a rule you can impose, and that is just a modification to the basic two-phase locking. We call it as conservative two-phase locking. So if I am following conservative two-phase locking, I have a separate slide for that. Just listen now. This deadlock issue will not be there. So in conservative two-phase locking, I will be locking all data item I am in need. For example, y, x, everything I need before starting the actual transaction steps. Say read item y, everything. So this read item y also, I will postpone, because what I have to do is, I have to ensure that this all this locking will happen before. So this you have to postpone like this. Okay. So this is and I will be locking a particular data item provided I am getting all data item I want. Okay, if any one of the item is being locked by someone else, I will release what I am having with me also, so that it will be used by someone else, at least he can proceed. So like that, any one of the transaction will voluntarily release, and the other one will be proceeding, and after that it will release all the variables. The first transaction can now proceed, something like that. So this is something a better variation of two-phase locking called a conservative two-phase locking, which is free from deadlock, and as it is two-phase locking, it is going to ensure serializability also. So this is just explanation of the phenomenon. You can just go through it, and see here it is explaining how this process is happening, and it is leading to deadlock, right? And by default it ensures serializability. I mean, if the schedule is following two-phase locking. And the problem, there are many problems, right? It limit the amount of concurrency, in the sense, means I'll be locking everything, right? If someone else is trying to lock that item, he has to wait like that. Whether I need it or not, I will lock everything that is needed for me in the growing phase. Then only I will start, I will move on to shrinking phase. So that time, even though that particular data item may be needed at a later point, but I want to unlock some other item. For that purpose, I will be locking this before. So like that, the amount of so we don't have any guarantee like how much concurrency I can ensure. So the amount of concurrency may be limited by this two-phase locking protocol. So that is the general issue with two-phase locking, whether it is normal one or conservative and all. Okay, so but it ensures serializability. It does not permit all possible. Even though it ensures serializability, by default, all non-serial schedule that follows this two-phase locking will be serializable. But there may be other serializable schedule also that is violating two-phase locking, and those things are not captured by this. Okay, so like that, just read it. Now the variations, these are important actually. So the first variation is conservative two-phase. The type of two-phase locking protocol that we explained so far is what we call as the basic two-phase locking. Now we have the very first variation called the conservative two-phase locking or static two-phase locking, because dynamically it is not locking and all. Before starting the actual execution, everything. So what are all the read items, and what are all the items I want to read as well as write? Let me pre-declare the set. Okay, let it as the read set and write set, and what I will be doing, everything I will be locking before starting the actual transactions. The read set of a transaction is a set of all item the transaction reads, right? Similarly, write set is a set of all item that the transaction writes. So the two-phase locking requires a transaction to lock all item, read as well as write, it accesses before the transaction begins by pre-declaring them and locking them. So definitely, if any of the pre-declared item, this is very important, because if any, not only pre-declaring and locking, if any of the pre-declared item needed for a transaction is cannot be locked, in the sense someone else already locked it, the transaction does not lock any item. It will simply release all item it locked already. Okay, if one of the item is missing, so it will proceed only when all item needed by the transaction it can lock. That point only it will proceed to the transaction. Okay, and it will silently say wait for that item to be released. Then once it is acquiring all locks needed, it will proceed. Okay, so definitely it is going to be free from deadlock. So it's very important. So the deadlock free variation of two-phase locking is our conservative locking. However, it is difficult to use it in practice because of the need to pre-declare things. So most of the practical cases, we may not be, because it's a kind of static approach, and dynamically the requirement will vary, and that time you can't pre-declare, you can't predict the requirement, right? So that kind of a inherent difficulty it is having. Now the next variation is strict as well as rigorous two-phase locking. So something, so here we are talking about the two-phase locking variation is a strict two-phase locking, but something similar you studied already, the strict schedule. So you just relate, I mean, when I discussed that recoverable, cascadeless and strict schedule, hope you remember in a separate video I discussed recoverable schedule, the concept of recoverability, and as a generalization for that I discussed that cascadeless schedule as well as strict schedule, and that time you just think about it, how it is working. Suppose a transaction is reading an item that is being written by some other transaction. What this transaction is supposed to do, it will wait until that item is that transaction which write the item is being committed. So that strict schedule is being ensured by the strict two-phase locking protocol, and let's see how it is working. And the most popular variation of the two-phase locking is the strict two-phase locking, and which ensures the strict schedule. Here, a transaction does not release any of the exclusive write lock. The restriction is only to write lock until after it commits or aborts. Okay, so what are all the data item I want? I will be locking them and I will be proceeding with them. And once the need is over, normally the two-phase locking protocol will release them. But here, the delete operation will be postponed after the commit or abort operation of the particular transaction which is using it. Okay, so now the benefit is like when the data item is unlocked, other people will be trying to get it, right? And that time this is already committed. So for a committed transaction, I am reading the data item which is written by it. So this is a requirement of strict schedule. Hope you remember. Okay, so that there is nothing like a cascading rollback or some write related issues. So strict schedule will postpone both read as well as write operation on data item which is written by some other transaction after its commit operation. So that is happening automatically because we are just postponing the unlocking operation of the data item, write data item after the commit. So automatically after that only other people can read it. Okay, or they can lock it and read it. So it will by default ensure that strict schedule. If you have any doubt at this point, please watch that video on the strict schedule which is following that recoverable schedule and come back to this. You can follow this. So that's all. So here the only restriction is on releasing the lock that is going to happen after the commit operation, and that is for write lock, not for read lock. Okay, read you can release at any point, you can unlock at any point, but write lock. So definitely there is no restriction on acquiring the lock. If I have the restriction on acquiring the lock like what happened in conservative locking, that will be deadlock for free. But here we have a restriction only on the releasing phase, not on the acquiring phase. So it is not deadlock free, right? So that deadlock can still happen. So just look at the rule, it is important. A more restrictive variation of the strict two-phase locking is rigorous two-phase locking. Actually it is more restrictive, which also guarantees strict schedule. So in rigorous two-phase locking, it will not release any of the lock. Strict two-phase locking, that restriction was only on the write lock the items. Okay, read lock can release at any point. So we have to restrict for write locked item for strict schedule. But if you are restricting for both read as well as write lock the data, let them unlock the data item after the commit operation. It is more easy to implement, and at the same time it is ensuring strict schedule also, and that is what is happening in the rigorous two-phase locking protocol. So hope it is clear. Strict two-phase locking will unlock all data item, unlock all write locked data item after the commit or abort operation of a given transaction. Wherein rigorous two-phase locking, it is more rigorous, it is more restrictive in the sense both read locked and write locked data item you can unlock only after its commit operation. Okay, yeah, that about it. So that's all about different variations of two-phase locking. Now some points that you can note down at this comparison page. Okay, so that is going to, so we are going to finish after explaining this particular PPT. So notice that the difference between strict and rigorous two-phase locking, strict and rigorous two-phase locking we just gone through, right? You know, in strict only we have restriction for the write locked data item, rigorous we have restriction for both. The former holds the write lock until it commits, whereas the later holds all locks until it commits. Okay. Now what about the conservative and rigorous two-phase locking? Conservative restriction is happening at the beginning. I mean, before starting any transaction, you are supposed to lock all the data item you are in need. If some of the item is not available, you don't lock in any of them. Just release all. So hope you remember. And rigorous two-phase locking, the restriction is happening at the end. So both are just opposite, right? So in conservative two-phase locking, we are imposing some restriction before starting the transaction, and here after committing the transaction, you have to release the locks, right? So restriction is at the end of the transaction. So the former must in the former we must lock all item before it starts. So once the transaction starts, it is purely going through the shrinking phase. In the sense, everything we needed we locked before starting the transaction. So once you start the transaction, you can see it is in the shrinking phase because only unlocking will happen, right? Now the later one does not unlock any items, unlock any item until after it's terminate by committing or aborting. So that says that the transaction throughout is in growing phase, and once it is committed, it will go to the shrinking phase, like that. So the transaction is in its expanding or growing phase until it ends. After that only it will move on to shrinking phase. So just opposite concept. and the purpose also different. Locking is generally considered to have a very high overhead because every read and write operation is preceded by a system locking request. So before starting each and every read as well as write operation on any data item, you have to lock it, and after completing you have to unlock it, maybe in some order like that. But this locking as well as unlocking operation you have to do execute in a atomic or indivisible manner also, and it's going to add too much overhead, right? So use of locks can also cause two additional problem. Deadlock is something we already seen, see where in the basic two-phase locking as well as in strict as well as rigorous two-phase locking we have this deadlock issue, but conservative two-phase locking is the only one which is deadlock free. Anyway, its possibility is there, and sometimes starvation also. Some people say particularly in conservative two-phase locking and all, if particular data item is not available, it will release everything and it will wait for someone else to release the data. So that may lead to some starvation. The same person may not get an chance to get the data, it will keep on waiting. Something it may starve for getting the data item. It can happen, right? Especially in conservative two-phase locking. Even though it is deadlock free, it is not starvation free. So that about it. Yeah, thanks for watching. So this completes the discussion on two-phase locking as well as its variations.